Hi, this is the second part of the correlation analysis video, and in this we discuss about types of relationships. There are the first one is strong relationships. This one is positive and this one is negative relationship. The central line, this black color, this is basically the fitted line. If the data lies too close with this fitted line, just like these are red, sterics are the data points. These are lying too close with this fitted line. So it means that the relationship is strong. And this line is going towards the upward. So relationship is positive. In the second case, again, this black line is the fitted one. The data lies too close with it, so relationship is strong, and the line is going downward, so it means negative relationship. In the third one, the data is lying scattered more as compared to the first two graphs. So the relationship is somehow you can say weak or moderate. The difference between the weak and the moderate can be easily made based upon the correlation coefficient based upon the numerical information. So again we can say line going upward positive and relationship can be weak or moderate, and likewise downward scattered too much as compared to these two, so it's a negative relationship. In these two graphs, first of all, there is no upward and downward movement. So it's quite clear that there is no positive or negative relationship. This one is the most ideal graph for no relationship. And in this case, we get our R value. The R is usually used to represent the correlation coefficient between two variables. Somehow, in few cases, we also use rho. In few software, it has been used the rho. In this case, the rho value is equal to 0. If we discuss about this graph, also there is no specific upward or downward pattern. So we say yes, the R or rho or correlation coefficient is equal to 0. There are two types of correlations. Number one, Pearson correlation, and the second one is Spearman. Pearson correlation is a parametric test. Parametric tests are those in which we have to satisfy some assumptions before performing those tests. If the assumptions are satisfied, we will apply the Pearson, and if the assumptions are not satisfied, we will apply the Spearman. There is slight differences in both of the result and the formulas. However, in this lecture, we will focus on the Pearson correlation. For mostly in the experimental data, we will use the Pearson. However, in the ordinal data, mostly we use the ordinal data. Example is Likert scale. The Likert scale, we will use those scale in the survey data analysis that you people perform in your bachelor or in your master PhD research work. So in that case, you will have to must use the Spearman correlation. If you are going to perform the correlation analysis in any software, you will have to mention which, either Pearson or correlation. Please select. So if you have continuous data, I suggest you people to go for the Pearson because it's the most appropriate one. But satisfy the assumptions first. This is the formula for the correlation coefficient. Here X means the individual values, X bar means that the average of independent variable. Okay, we have two kind of variable there. One of them is represented by X and the second one is represented by Y. Most commonly, we apply a regression analysis after the correlation. So that's why we represent one variable with the X and the second one with the Y. In most cases, X represents the independent variable and Y represents the dependent variable. In the first part of this lecture, I told you people that we have an example of smoking. Increase in the number of smoking cigarette will result in the increase of mortality rate. So obviously in that case we have X over number of smoking cigarette, because the number of cigarette smoking is the independent variable that is represented by X, whereas the mortality rate, how many number of the people who die, it depends upon. So that's the dependent variable and it depends upon this X. So we represent this one with the Y. So X bar is the average of independent variable, Y bar is the average of dependent variable. It's a very simple formula. Based upon the value of the R, we take the square of this R and we get R square value, that is known as coefficient of determination. So coefficient of determination means, for example, we find the correlation value equal to 0.80 between number of smoking cigarettes and mortality rate. By taking the scale of 0.8, we will get 0.64. Now this 0.64 is the coefficient of determination. What this explains? It explains that 64% of the variation in the mortality rate, that is a dependent variable, has been explained by our independent variable number of smoking cigarettes. In simple words, there are a lot of the factors that affects the mortality of the people. Okay, so as the result are saying that 60%, 64% of these mortalities are due to the smoking of cigarettes. In the next part, I will explain the data and we'll start the analysis. Thanks for watching the video. Bye.